In the second part of this two-part video, we're going to look at a similar but slightly different problem. In this problem, it says a farmer hitches her tractor to a sled loaded with firewood and pulls it a distance of 10 meters along a level ground. The total weight of the sled and load is 15,000 newtons. The tractor exerts a constant 4,000 newton force at an angle of 32 degrees above the horizontal. A 3,200 newton friction force opposes the sled in motion. Find the work done by the normal force, friction force, and tension force. Find the total work done by all the work components. Once again, to save time, I drew a diagram so that we can visualize the problem better. Like we did in the last video, before we can solve, we must establish the x direction, which is going to be the same direction as the displacement, and the y direction. To solve this problem, we need to determine the normal force, the friction force, and the tension force, so that we can find its individual work component. In this problem, we were given the normal force as the weight of the sled and the load, which is 15,000 newtons. So the normal force is equal to 15,000 newtons. The friction force is also given by the problem, and it equals 3,200 newtons. So the friction force is equal to 3,200 newtons. And the tension force is going to be the force the tractor is pulling the load. And that's going to be a constant 4,000 newtons. So the tension force is equal to 4,000 newtons. However, this is not a tension force we're going to be using to calculate our work done by the tension force. The reason is because the tractor is pulling the load at an angle, meaning the tension force vector is at an angle. And if you remember from Unit 3, whenever we have a force that's at an angle, we must break up the force into its x and y components. So here we must do the same thing. Now let's use a different color to mark up our x and y components. So this will be the tension force in the x direction, and this will be the tension force in the y direction. Now you may be wondering, which force component are we going to use for our calculations? Well, if you think ahead, the reason we're solving for force is because we want to know the work done by the tension force. And we know that force vectors that are perpendicular to the displacement, like normal force, are going to have 0 joules for work done. With this in mind, we see that the tension force in the y direction is perpendicular to the displacement, so it's going to have 0 joules for work done. While the tension force in the x direction is in the same direction as our displacement, so it's going to be a positive work done. So when solving for work, we're going to be using the tension force in the x direction. Now that we know this, let's go ahead and solve for the tension force in the x direction. But let me first change my color. So if you remember from Unit 3, we use trigonometry to solve for the horizontal component of a force vector. So in this case, the tension force in the x direction is going to equal the tension force times the cosine of theta, where theta is this angle over here. So the tension force in the x direction equals 4,000 newtons times the cosine of 32 degrees. And this will roughly equal 3,392 newtons. Now that we know these three force values, let's solve for the work done by each of these forces. The work done for the normal force is going to equal 15,000 newtons times 10 meters, since that's the displacement, times the cosine of 90 degrees, because again, it is perpendicular to the displacement. And this is going to equal 0 joules. So again, forces that are perpendicular to the displacement are going to have 0 joules for work done. The work done by the friction force is going to equal 3,200 newtons times the displacement, which is 10 meters, times the cosine of 180 degrees, because it is opposite of the displacement. And that's going to equal negative 32,000 joules. The work done by the tension force is going to equal 3,392 newtons, because this is the force we're going to use, times the displacement, which is 10 meters, times the cosine of 0 degrees, because they're both in the same direction. And this will roughly equal positive 33,921 joules. Make sure to use the exact value you calculated earlier. Finally, the total work done equals 0 joules from the work done by the normal force, plus the work done by the friction force, which is negative 32,000 joules, plus the work done by the tension force, which is positive 33,921 joules. And this will equal positive 1,922 joules, approximately. With that, hopefully after completing these two problems, you have a better understanding on how to approach problems where it asks you to solve for work for each individual component, as well as solving for total work where the force vector is at an angle. Thank you for watching this video and hope to see you next time.